So today we're talking about absolute value equations. Hopefully we've all heard about absolute values before. The one thing to remember with absolute values is that once you simplify what's inside of the absolute values, when it comes out, it becomes positive. Absolute values talk about the distance a number is away from zero. So basically distance, and if you think about it, let's say you're driving your car, or the car that you're going to get after you spend it, your $1 million. But even if you drive backwards, you're still going a distance, correct? How many of you have seen Ferris Bueller's Day Off? So don't you remember like how they're trying to take the miles off by going backwards, but it actually adds miles? So just remember absolute value is dealing with distance. So it's always going to be positive, but you have to always simplify inside the absolute values first. These are basically like parentheses, okay? All right. So let's go ahead and go down here to example 1. So this starts out kind of simple. Once your absolute value is by itself, you're going to set up two equations. So I normally go ahead and just write the two equations. So I have k plus 6 equals 9, and k plus 6 equals negative 9. So the reason why this one is negative is because inside it could be a negative 9, but when it comes out, it's going to end up being a positive 9. So that's why we're doing the negative equation, because we're talking about what's inside could be negative, but it's going to come out as a positive. And then we solve both of these. So in order to get k by itself, what do I do? Good. Subtract 6 to both sides. So I end up with k equals, and 9 minus 6 is 3. Okay, over here, I do the same thing. I'm subtracting 6. What happens when you have two negative numbers? Very good. You add them and it stays negative. It's like you borrowed $9 from your parents and you're like, can I have $6 more? And they're like, yeah, but they add the 9 and the 6 together and now you owe them 15, right? So remember, two negatives you add and it stays negative. So those are my two answers. K equals 3 and negative 15. Okay, what do you notice is different from example 1 to example 2? Exactly. There's a negative 2 outside of our absolute value bars. Okay? Yes?
But that means you have to multiply it and distribute it?
Close. What we're trying to do is we want our absolute value bars by themselves. Okay? We want, and you're right that it's like parentheses because it's meaning negative 2 times this, but we're not going to distribute it. How else, if something's multiplying, how do you get rid of it? Divide. So in order to get rid of it, we are going to divide both sides by negative 2 to get rid of the negative 2 in front of the absolute value. So now I have the absolute value of x plus 3 equals, and 6 divided by negative 2 is what?
3.
Close. Negative 3. Good. Okay, so we need to think about this for a minute. We know that inside here we can have a negative number, but when it comes out, it's always going to be what? Positive. So once your absolute value is by itself, if this number is negative, that means the answer is going to be what? No solution. Because there is no way of having a negative in here and it coming out and being negative. Any number in here, when it comes out, it's going to be a positive. So this answer is no solution. Or instead of writing no solution, you can do your 0 with a line through it, and that means no solution. If I wrote just 0, that would be an answer, which would be wrong, but 0 with a line through it means no solution. Do we get that part? Are we all thumbs up? Yes, I get it. In the middle, so down means no. I have no idea what you're talking about. So if everybody can give me a thumb one way or another, that would be awesome. Okay. All right. Okay, moving on. So example 3. Again, there is the absolute value by itself right now? No. So what are we going to do?
Divide.
Very good. And we're going to divide by?
3.
To which side?
Both sides.
Very good. Trick question. Okay, so we're dividing by 3 to both sides. We have the absolute value of 2x minus 1 equals, and 3 goes into 45.
15.
Very good. Okay, at this point, who knows what I'm going to do next?
You're going to
Very good. And one problem is going to be?
Negative and one's going to be positive.
Amazing. Okay, 2x minus 1 equals 15. And 2x minus 1 equals negative 15. And someone besides Michaela, tell me, McKenna, sorry. Tell me, why am I writing two equations? Why do I have one equation that's positive and one that is negative? Who knows? Pretty soon, and these are all from last year, but I'm going to have your names like on popsicle sticks, and I'm just going to draw one, and someone's going to have to answer. But nobody wants to answer me right now? You guys don't remember, or we're just scared? Thank you. Okay.
Isn't it the point plot on
Say that again.
the point plot on
The grid? Well, yeah, we could end up plotting these, but like, why do I have two equations? Like, why do I have to have a positive one, and why do I also have to have a negative one? Because what happens when you have the absolute values? What happens? Inside, it can be what? It can be negative, but when we pull it out, it's going to be positive. So there's always going to be two answers. So we have to set it up as negative 15 because inside it could be negative 15, but then when I pull it out, it'll be positive. Okay? So we're going to solve these. So we add 1 to both sides. We have 2x equals, and 15 plus 1 is what? Very good. And then right here, the 2 and the x are doing what? They're multiplying, and in order to undo multiplication, we divide. So we get x equals 8. Over here, we're going to do the same thing. We add 1 to both sides. What happens when I have a positive and a negative number? Good. Subtract and take the sign of the... Very good. So 15 minus 1 is 14. Excuse me. But it's going to be a negative because 15 was larger. Then I divide by 2 to both sides, and we get x equals negative 7. Oops. So my two answers are x equals 8 and negative 7. Does this seem blurry to you guys? A little bit or no? That's better. Now, example 4 is a little bit more tricky. We are trying to get our absolute value by itself. Okay? This says 7 minus 3 times 3x minus 6. Because remember, these are like parentheses. Okay? What's tricky about this is a lot of people want to go 7 minus 3 is 4, and that is not correct. Okay? Because this negative 3 isn't being added and subtracted. It's actually being what? Multiplied. But the 7 is like an adding and subtracting number. So you're first going to get rid of the 7, and then you're going to take care of that negative 3. So be really careful. You can't combine these at this point right now. Okay? You can't go 7 minus 3. Because this 3, since it's right next to that, it's meaning multiplication. Okay? So in order to get rid of this 7, we do the opposite of adding 7, which is subtract 7 to both sides. Good. So now, and I don't forget about your negative in front, so I have negative 3, absolute value of 3x minus 6 equals, and 14 minus 7 is 7. Okay, what would be my next step on this problem?
Divide by negative 3.
Perfect. Divide by negative 3 to both sides. Now, once I do that, I notice that I have the absolute value of 3x minus 6 equals negative 7/3. Well, when your absolute value is by itself and you have a negative answer here, we know the answer is going to be what? No solution. Because we can have a negative inside, right? But it'll come out as a positive. But we can't have a negative outside our opposite values. All right. Example 5. Last one for today. So again, I'm going to set up two equations. I always like my x to be on the left and my number to be on the right. So I'm going to rewrite this as 2x minus 1 equals 2/3. And 2x minus 1 equals?
Negative 2/3.
Good, negative 2/3. Now, how many of you like fractions? You like fractions? That's awesome. Good. I personally, fractions are okay, but they're not my favorite. Whenever you have an equal sign, which makes something an equation, you can get rid of your fractions by multiplying every single term by your common denominator. So on this problem, what would be my common denominator? 3. Okay, because 3 is the only denominator I have. So what I would do to get rid of my fractions is I'm going to multiply every single term in the problem by 3 so that I can get rid of my fractions. So when I do that, my new equation is going to be 6x minus 3 equals, and on the last one, the 3 and the 3 cancel out, and I get 2. And again, the whole purpose was to get rid of the fractions. So if you do this and you don't get rid of the fractions, then you did something wrong. Okay, and we can do the same thing with our other equation if we want to right now. Again, what am I going to multiply every term by?
3.
Good. So we write 3 next to every single term. 3 times 2x is 6x. 3 times negative 1 is negative 3. Equals, and here my 3's cancel out, which was the purpose, and I'm left with negative 2. And then now I can solve both of these equations. So here I'm going to go ahead and add 3 to both sides. And I have 6x equals 5. And the last step would be what? Good, divide by 6. So x equals 5, 6. On the other equation now, I'm going to add 3 to both sides. What do I do with a positive and a negative?
Subtract.
And take the sign of the? Good. So 3 minus 2 is 1, and it'll be positive because 3 is larger, and it's positive. And then we divide by 6. So my two answers are x equals 5/6 and 1/6.